Alright, so we're just going to do a quick overview of kinetic energy calculations and then doing work kinetic energy problems. So to start, our kinetic energy formula is 1/2 times m times v squared. And so if we want to calculate, let's say we have 40 joules of energy and the object has a mass of, say, 2.5 kilograms. Actually, we'll say no, 5 kilograms, and we would want to know what's the velocity of that object. Okay, well, we can use our kinetic energy formula, so we'd say 40 joules. So, right, kinetic energy equal to. So, 40 joules would be equal to 1/2 times our 5 kilograms times our v squared. So 1/2 times 5 is 2.5. This is equal to 40. We divide that 2.5 over. We'll bring it up here. So 40 equal to 2.5 kilograms times v squared. These are joules. We divide 2.5 to both sides. 40 divided by 2.5 is going to be 16. Equal to v squared. We take the square root and we get a velocity equal to 4 meters per second. Now we did take the square root, so technically it's like a plus or a minus, but we're just going to ignore the sign for this. Okay? And so we have a velocity there of 4 meters per second for that object to have a kinetic energy of 5 kilograms. Okay? And there we have it. Let's do another example. So let's say now we have an object with a mass of 10 kilograms and a velocity equal to 5 meters per second, and we want to know how much kinetic energy it has. And so we use our kinetic energy formula, 1/2 times m times v squared. So in this case, that's 1/2 times 10 kilograms times our 5 meters per second, and we square that, and so 1/2 times 10 is 5. 5 squared is 25, so 5 times 25 is going to give us 125 joules of kinetic energy for this object. Okay, and so we could also solve for the mass if we wanted to, but hopefully you kind of get the idea of how this works. Okay, the next thing we'll look at is how to now analyze a problem where work is being done. So let's say that we have an object that's not moving, or let's say, okay, so yeah, let's say we have an object. We're going to apply a force of 20 newtons on it, and we're going to push it a distance of 3 meters, and let's say this object has a mass of 7 kilograms. Okay, so what we're going to do here is we're going to make a chart, an LOL chart, and we'll say, okay, at the beginning this object had no energy, at the end it has kinetic energy, and that kinetic energy increased, and that energy came from work being added to the system. Work done by this push, right? So work from the push. And so we'll say, okay, to write our equation, work from the push is equal to kinetic energy at the end. Well, work is force times displacement, and kinetic energy is 1/2 times m times v squared. So we can solve now for the velocity of this object. And so we'll say, okay, the force is 20 newtons, the displacement was 3 meters, the mass of this object is 7 kilograms, and we're solving for v. So 20 times 3 is 60 joules of energy that was added. 1/2 times 7 is 3.5 kilograms, and then we have the v squared. So we'll divide 3.5 to both sides, and 60 divided by 3.5 is going to be 17.1. And then if this was a joule, which is a kilogram meter squared per second squared, if we divide out the kilogram, we're left with meters squared per second squared. So this is 17.1 meters squared per second squared equal to v squared, and we'll just take the square root of both sides, and the square root of 17.1 would be like 4.2 or something. Let's see, maybe 4.1. Yep, 4.1. So velocity is equal to 4.1 meters per second. Okay, we'll do one more example here, and I think that should be sufficient. Okay, so this time, let's say that we have a car. It's got some wheels. This car has a mass of 1,500 kilograms, and it's traveling with a speed of 20 meters per second. And let's say that it's going to stop in a distance of 5 meters. And so we want to know how much force is required to do that. Okay? And so you notice that we're kind of cheating here with the signs with the work. And it's because of the way that we're setting up our equation. So we're going to do a before and after chart, or a LOL chart. So we start with kinetic energy. Okay? That kinetic energy goes down because of work done to pull the energy out of the system. Now, we could also call it thermal energy being created, that's fine, but we want to do work so we figure out how much the force is. And so kinetic energy equal to work, that's 1/2 times m times v squared equal to F times displacement. And so this is 1/2 times 1,500 times our 20 meters per second squared equal to F times 5 meters. Okay? And so if we multiply that, so 20 squared is 400 times 1,500 divided by 2 is going to give us 300,000 joules. We'll divide that by 5 and get that the force was equal to 60,000 newtons. Okay? So there was some examples of calculating kinetic energy and doing work problems with kinetic energy. Hopefully that was enough to get the idea and get started on these. Let me know if you have any questions. Hopefully you're doing okay with it.